Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alright, let's take a look at our homework for lesson 8.1.1. This is specifically on simple interest, and we are reviewing this basic concept from 7th grade. Remember, simple interest is interest that is only paid on the original amount. Compound interest is something a little bit different. We'll get to that a little bit later, but right now we're just focusing on the simple interest. And the formula I equals PRT, each one of these has a meaning. The principal is the amount that you deposit or borrow. Maybe I'll write that in here. Now let's change it to this color. Okay, so you either borrow this amount and it's called a loan, or you deposit or save that amount if you, I guess it's a deposit if you save it. Okay, interest is the amount earned over time. Interest rate, that's your percent. What percent are you charging it? And time can be in years, it can be in days, it can be in months, it can be any unit of time, okay? So when we go through and work the 5D process as it pertains to simple interest, we want to define all of these variables. This is what we're talking about. Here's the formula we're going to use when we do the problem. And of course, using our calculator and just a little bit of logic and estimation to check to make sure it makes sense. So here's the situation. Teresa invested $1,425 into the savings account. It pays simple interest at 3.5%. So you're going to change that 3.5%. Let me actually highlight. This is the principal. This will be the percent. So you're going to take I equals PRT. The principal, 1425, times the percent in decimal form. And then the amount of time, it's annually, so that's going to be per year, so 4 years. So generally, what I like to do is I like to figure out how much money per time unit, in this case per year, would you earn. So I would take 1425 and multiply that times 3.5%, which is going to be 0.035. And that is $49, and okay, we're going to round that to $49.88. So this would be like I is going to be $49.88 for every year. But now that I've rounded it up, it's going to affect the overall balance a little bit. So I should probably just leave it like this so that it doesn't affect the overall balance because of my rounding, even though that's not a real, that's like 87.5 cents. And now you multiply that times 4. And that gives you how much interest has been earned. So you earned $199.50. Well, this is the amount of money you invested. That's yours. You don't have to give that up. The bank thanks you for letting them use your money, and they pay you interest of $199.50 over that 4-year period. So when you withdraw that money from the account, you are withdrawing $1,624.50. That is your new money because you earned interest. Now, someone asks, why would the bank pay you money to just put your money in the bank? Well, something to be aware of here. First of all, 3.5% interest is nothing. The bank will not pay you that. The bank is more likely to give you an interest rate that is like 0.01%. It's terrible the amount of interest that they pay you. If you even got 0.1%, I would be surprised, but maybe some will pay you that. Okay, but when they turn around and they loan your money out to someone else, if they take your $14.25 and agree to pay you interest, they're going to loan that to someone else for a lot more money. Okay, so let's just pretend, yes, some bank actually gave you 3.5%, but when they turn around and lend that money to someone else, they're going to maybe lend it out for 7%. So they're going to collect $400, and they're going to give you 200 of it, or $199.50, and then they're going to keep the rest. That's why banks stay open, because they charge more money for a loan, they charge more interest for a loan than what they're willing to give you for a savings account. And for you, it's like, well, that's unfair. Well, you don't have to give them your money to free country, you can keep it under your mattress and not earn any interest at all, which some people do. But that's how they encourage you to give them your money by offering you interest, and then they turn around and lend your money and charge a higher amount of interest. That's how banks make their money. Okay, Cassandra is calculating how much interest she will earn on investments that earn simple interest. She knows that simple interest is only paid on the original amount, the principal. For one amount of money that was invested for 3 years, she wrote this. So here's your principal, $500. Here is your interest rate in decimal form. Here is the amount of time, which it says right there was 3 years, right? So, and this is the amount of interest earned. So based on this, I can tell you what the interest rate was, what the amount of time was, and what the principal is. Principal was $500 because I equals PRT. The interest earned was $37.50. Can you see that okay, hopefully? The interest rate is 2.5% because remember, let me go ahead and do this in green. 0.025 is the same as 2.5%. What was I thinking? I don't know what I was thinking there. But remember, to convert from any decimal to a percent, you move the decimal 2 places to the right. If you want to prove that, remember, percent, this is what I was thinking. A percent means out of 100. So if you took 2.5 and divided it by 100, that would give you the original amount. 2.5 divided by 100 gives you this decimal number right there. So yes, we know that going through the conversion between decimals and percents, this is the percent, and then the time in years was 3 years, and it already told us that. Okay, so use this formula to calculate how much interest you would earn on a deposit of $200 for 5 years at a simple interest rate of 4%. So remember, I equals P, which is 200, times the interest rate, which is 4% in decimal form, 400ths, times the amount of time, in this case, per year for 5 years. Okay, if that said monthly for 5 years, you'd have to do it for 60, because it would be 5 times 12 is 60 months in 5 years. But it's yearly, which is annual, for 5 years, so the 5 goes there. So I want to figure out how much interest is earned per year. So 200 times 4% means that is going to be $8 per year, times 5 years is a total of $40, which is what we see right there. All right, which is the better deal? Sabrina wants to buy a new digital camera. The one she wants is currently on sale for $300. She could borrow the money at a monthly interest rate, that's monthly, of 4% simple interest and pay it off in 6 months. Okay, so the time, it's monthly for 6 months. The principal is $300 and the interest rate is at 4%. Her other option is to work for 6 months and then pay cash, but the camera won't be on sale and she's going to have to pay $350 if she waits. And I'm not sure about you, but I'm not really good at waiting. I want to get it now. I'm willing to pay. I don't know. Maybe we could just save the money and do it the old-fashioned way before we had loans and credit cards and everything, and just wait and just pay the regular amount. But $300, that's a good price. So maybe you'll save enough money here to afford that interest that you would have to pay. So let's check this out. I equals PRT. We're going to plug in the principal, the interest rate, and the amount of time. And I did it a different way this time. It doesn't really make any difference which direction you go when you multiply. You can multiply 6 times 400 to give you 2400ths, and then multiply that times 300, which is 372. Or you could have taken $300 times 4%, which is $12 per month. She's going to have to pay back in interest. 12 times 6 is 72. So that would be, wait, what is that? No, that's the new amount. Oh. Okay, so I should probably change this. Can I erase that? No, I can't. I'm going to cross it out using my black marker here. The interest would have been $72. But the new amount is going to be, when you add the $300 that she has to pay back plus the 72, means that it's actually going to cost her $372. Is it worth the extra $22 to have the camera now rather than waiting 6 months? Some people would say yes. Some people would say no. Either way, bottom line, it's going to cost $372 to finance $300 for 6 months. Or if you just work and then pay the regular price, it'll cost $350. All right, Mighty Max started the wrestling season weighing 135 pounds. By the time the season ended, he weighed 128. What was the percent decrease in his weight? All right, so going back to 7th grade when we were talking about percent change, to find the percent increase or decrease, you got to find the amount of change and write that as a ratio over the original weight. This can be converted to a percent, which would be your percent change. And so you know if it's going up or down. So there is this formula we said was N minus O over O is equal to percent out of 100. This is the ratio of the change in weight, the new amount, over the or minus the original amount, ended up giving you a negative number of pounds, right? But I would just take 135 minus 128, which is 7, and just know it went down, so it's going to be a decrease, right? And so once you get 7 over 135, what percent is that the same as? Well, now we're going to use our percent proportion. And in this case, I would probably cross multiply here because there isn't a real giant one that's easy to find here. So you can cross multiply, or some of you may just choose to take 7 divided by 135 and then move the decimal 2 places to the right. That works too. There are lots of different strategies you can use here, but I'm going to go with what we worked on so extensively last year. Cross multiply and then take 700 divided by 135. Now notice what is happening here. When I take 7 and divide it by 135, I get this decimal number. And then when I multiply that decimal times 100, it moves 2 places to the right, which is 5.18, which I rounded up to 5.12. If I do it this way, I started by multiplying 7 times 100. Then, after getting that answer, then I divided it by 135, and I get the same answer. So it doesn't matter if you do the division first or if you do it last. You're still going to divide by 135, and you're still going to multiply times 700 to get this as a decimal number, which rounds to 5.2% as the decrease. All right, distributive property and factoring. They are opposites of each other. If you recall, we talked about a lot using distributive property, sending in dive bombers. If you've already got an expression where you want to factor it and rewrite this in a different way, you can do it like we do with fractions and look, what is the greatest common factor of those two terms? They have 2 in common, but they also have 4 in common. So if I divide both of them by 4, 4 divided by 4 gives you the 1x, and 8 divided by 4 gives you the 2, and we had factored out the 4, so we would write it on the outside. Check it to make sure when you send in the dive bombers that you get back to where you started, and we did. 4 times x is 4x, and 4 times 2 is 8. So here, what do the negative 45 and the negative 5 have in common? Well, they have negative 5 in common. Now, some people might have just factored out a 5 and called this negative 9 minus x, and that would have been okay too. So it's always a little tricky if you've got some negative signs in there, whether or not you factor out the negative sign as well. It's essentially factoring out negative 1 with the 5, so it's negative 5. And then these guys stay as positives on the inside. It's purely your choice. Generally, I would like to have a clean expression on the inside. And by clean, I mean I don't want too many negative signs. I would tend to do this and divide these two terms by negative 5. Here, you've got 7 and negative 21. I'm going to go ahead and take out the 7. So it becomes 7 times x is 7x, and 7 times 3 is 21, and there's a minus sign there. Someone might have said, well, what about negative 7? And you could do that, but then this would be negative x plus 3, or 3 minus x if you wanted to reverse those, but I wouldn't do either one of those. This is by far the easiest one. All right, relative frequency tables. Do I want to spend the time on this problem? Oh, how much more do we have to go? Hey, okay. Well, let's just do a snapshot of it. I won't go into details. School counselors are worried about study habits of students who are involved in a lot of after-school activities. Oh, I like this problem. Okay, we'll spend the time on it. They randomly selected students at school and gathered the following data. Okay, so consider the number of activities to be or the number of hours, I should say. It's the number of hours spent doing activities. This is going to be your independent variable, and you're trying to see how it affects study time. Whether you study less than 8 hours per week, that's per week, not per day, or 8 hours or more per week, okay? I don't think these totals are necessary. Let's, I'm gonna do something here. Let's get rid of that. Okay. We don't want that distracting us. Or do we? Oh, I think I did it the other way. I guess we do want that. These are the ones that we don't want. All right, let me get that guy out of there and do this. So I'm just wasting your time, but I have OCD. I don't know that it really makes any difference. I think we can still draw our conclusions, whether we do it this way or that way. But honestly, I think I was supposed to have done it this way originally, but we'll still draw the same conclusions. Okay, so this means that of all the people who had less than 5 hours of after-school activities, 29 of them studied less than 40 or 8 hours per week, and 19 studied more. So that means that 60%, 29 out of the 48, which is it's like 60.4, but I call it 60% of the students who did not have as many after-school activities studied less than 8 hours, and 40% studied more. You take the ones who had 5 hours or more of after-school activities, like maybe they're involved in clubs or sports or something along those lines. 14 out of the 50 studied less than 8 hours, and 36 out of the 50 studied more than 8 hours. So that's 28 versus 72%. So look at these percentages. That's a significant difference. Look at these percentages. This is also significant. 72% of the people who had more activities after school studied more than 8 hours. That tells us that there is an association here. Students who have more after-school activities tend to study more. That seems backwards, but you cannot deny the data. So let's try and explain why that would be the case rather than try and prove that this data is wrong because it doesn't agree with what we think is supposed to be the correct answer. Obviously, what most people think and what the school counselors were thinking was wrong. So what could explain this? And I'm going to provide you with a bit of my own personal experience. Back in the days when I used to go back home and visit my family in Michigan, and my nieces were growing up, they were in middle school and then high school, I would often go to like basketball and volleyball tournaments to see them play. And my niece, Corey, she played lots of sports and spent lots of hours after school practicing for volleyball and then going to the volleyball tournaments. Well, guess what? During those tournaments, during that time that she's waiting to get onto the floor to do practice when it was a day for practice, there was a lot of sitting around doing nothing. So all of her friends, all of her teammates would sit around and they would complete all of their homework. They would do all of their studying during their downtime because they had nothing else to do during that time. Well, guess what happened with Corey? She ended up being school valedictorian. And she got a 4.0 all the way through high school. So she had lots of after-school activities, but those activities forced her and the other teammates to compartmentalize their time and make sure that they got their studying done. Now, contrast that with someone who goes home right after school and immediately gets a snack out of the kitchen and sits down at the computer or at their iPad or at their television and decides they're just going to relax a little bit because they've just spent all day long working in school. Totally reasonable, right? And one TV show turns into another TV show. Gaming turns into 4 hours of playing your favorite games with your friends. And the next thing you know, it's dinner time. The next thing you know after that, you're approaching bedtime. And you didn't get more than 1 or 2 hours, maybe, to complete your homework and do any sort of reading or studying. So these people have to schedule their time. And so by doing that, they end up building routines where they build in a lot more study time than people who don't have a lot of after-school activities. So let that be a lesson to you. After-school activities are good, but what's even better is compartmentalizing your time and planning for your study time so you make sure you get it done. All right, last particular problem, what do we have for our known measures? It looks like we've got those right there. So we are going to take our ratio, which is, what is our scale factor? Looks like it would be 33 over 22, which is the same as 3 over 2, or going in the other direction, 2 over 3. Okay, so we're going to multiply x times, oh, something is, or no, that's a z. Something is wrong here. What is going on? This is smaller than that. But this number is bigger than that. Okay, this is CPM trying to mess with you. Okay, they don't want you estimating. They don't want you to declare that z is a number less than 15 because they want you to recognize the scale factor says that z technically is supposed to be bigger than 15. And so you take 15, and I'm going to write that as 1.5. If you take this times 1.5, you end up getting 22.5, or 15 over 1 times 3 over 2 gives you 45 over 2, which is also 22 and a half. So z is 22 and a half. X, you're going to have to multiply x times 2/3 to give you, no. 40 times 2/3 would give you x. So 40 over 1 times 2 over 3 gives you 80 over 3, and 80 divided by 3 ends up being 26 and 2/3. And then this is the one where y, this needs to become bigger, so y is going to be 54 over 1 times 3 over 2, which ends up being 162 over 2, which ends up being 81. So, scale factors. We've got a lot of practice with that. The only thing different about this is CPM's shenanigans of giving you a smaller shape, but the numbers show that it's supposed to be larger. All right, I think that's it. We are done. Sorry about the extra time that I took, but I really, really wanted to walk through this problem right there because that's a good problem. All right, take care. Bye.
Hey, feeling good.